Hello, and welcome to an introduction to kinematics. Kinematics refers to the way of analyzing the motion of objects using physics. There are a couple of types of motion. The ones that we'll be referring to in this introduction are linear and circular motion. An example of linear motion is something simple, just like a ball being thrown to the right. And an example of circular motion can be something like a wheel spinning and a spot on said wheel being tracked to see where it would be at a certain point in time while the wheel itself is still moving to either left or right directions. But first, we should discuss what is a location in free space. So if you were to create a grid, and in this example, A represents a point at 4, 5, you divide that into X and Y coordinates and just plot that exact location. Then from there, we can define what velocity is. Velocity equals to the distance divided by time. And another way of saying that is that velocity is the rate of change of your location. So that basically you know that over time you are moving from where you had started originally. So if you were moving at 2 meters per second and you started at 4.5 and the motion is only in the x direction, you would be at 6.5 after 1 second. Alright, now if we use that same logic, we can define acceleration the same way. Acceleration is the rate of change of the velocity. So whenever you are traveling and you see that your speed changes, you are being affected by an acceleration. Now, there's a small difference between velocity and speed. Velocity is speed that has a direction. Speed is just a general number. That's the differences between them. Now, for the following kinematic equations that I will jot down, you require a constant acceleration. If you were to have an acceleration that is not constant, then the relationships that I'll jot down would break down. Basically, because there would be more variables. So not only would the velocity, the time, position would be changing, but the acceleration as well. Meaning that you can't draw simple relationships between them. Now, if we put everything together, we can define some equations for linear motion, like v equals to a times t plus v naught, where v naught is the initial velocity. V squared equals to v naught squared plus 2a delta x and x equals to x naught plus v naught t minus 1/2 at squared, where all the variables with knots on them, the little zeros, means initial values for that. And fortunately, circular equations have the same relationships. So all we have to do is just rename some of the variables so that it will be circular velocity and circular acceleration and angular position instead of just linear terms. Oh yeah, one last thing before I forget. The average velocity I did not list here, but it's basically the final velocity minus the initial velocity over 2. Thanks for listening. Do hit that like button and subscribe button, and I'll catch you guys on the next video. Bye.